From old-school CRTs to cutting-edge quantum LEDs. Today, I am inviting you on a beautiful journey through over 100 years of insane innovation in display technology. We'll break down every major display type, how they work, and where you can find them. Let's start with the classic. CRTs, cathode ray tubes, also known as the brain tube, icons of the 80s and 90s. The prototype was introduced in 1897, however, it took a couple of decades before they became available for commercial use.
They obviously want their picture to look as good as it possibly can.
A CRT works with an electron gun that forms images by firing electrons onto a phosphor-coated screen. Early CRTs were black and white only, while the first commercial color CRTs appeared in the mid-50s. For over 50 years, they dominated television sets and computer monitors. They offered good color reproduction and motion handling, but at the cost of weight, heat, and bulk. By the mid-2000s, flat panels pushed them into history. A plasma display panel uses tiny cells filled with plasma and ionized gas. Fun fact, gases ionize under extreme heat. For example, the sun is basically a giant ball of plasma. In displays, the same effect is created by applying high voltage in a tiny space. Think of it as a mini neon sign inside every pixel. Plasma TVs were the first large, over 32-inch, flat panel displays released to the public. Liquid crystal display. This was probably the biggest revolution in display history, enabling cell phones in the pocket, laptops in the backpack, and digital watches on the wrist. For example, the first iPhone shipped with an LCD.
This is one device. And we are calling it iPhone.
They don't produce light by themselves. Instead, a backlight shines through liquid crystals that twist to block or allow light, forming the image. LED. Here's a common misconception. The LED part only refers to the backlight. Instead of fluorescent tubes, LED-based LCDs use tiny light-emitting diodes as the light source. This allows for better contrasts, deeper blacks, higher brightness, and thinner designs compared to traditional fluorescent LCDs. OLED. Here, the emissive layer is an organic compound film that emits light when the current flows through it. But what are these compounds? They're special carbon-based semiconductors capable of transporting charges and emitting light. Each pixel produces its own light similar to plasma but with a completely different principle. This gives OLEDs perfect blacks and infinite contrasts. Today, they're considered the gold standard for high-end TVs and smartphones. Drawbacks: OLEDs are generally less bright than competitors and may suffer from burn-in if static content is displayed for too long, though this is rare in modern sets. Pro tip: since darker OLEDs pixels use less power, switching your device to dark mode can save your battery and lower the electricity usage. QLED and miniLED. Two modern alternatives typically cheaper than OLED. The Q stands for quantum dots, a thin film of nanoparticles placed in front of the LED backlight. Excited by blue light, they produce vivid white colors and very high brightness. Of course, there are some drawbacks. Because QLED still relies on a backlight that illuminates zones rather than individual pixels, it can't achieve perfect black and may show halo effects around bright objects on dark backgrounds. miniLED, considered generally better than QLED, by using tens of thousands of tiny LEDs, the display can create many more local dimming zones. This allows for much more precise control over brightness across the screen. miniLED often combines with a quantum dot layer. This gives the best of both worlds. Some brands market this combo under name like Neo QLED. E-paper, also known as e-ink. This technology was commercialized by the E-ink Corporation in 1997. Key properties: extremely low power consumption and excellent readability in bright light. E-paper displays use millions of microcapsules, each acting as a pixel with black or white ink. The microcapsules are sandwiched between electrodes. To create an image, an electric field is applied to the electrodes for a specific pixel, moving the particles up or down to display black or white. Image retention. This is the most crucial feature. Once the charged particles are moved into position, they remain there and hold the image indefinitely, even after the electricity is completely cut off. The display only consumes power when you need to change the image, for example, turn the page. Unlike other displays, e-paper doesn't emit light. Instead, it just reflects ambient light like a real paper. making it comfortable for reading in sunlight and reducing eye strain. Of course, these aren't all display technologies. For example, the Nixie tube, an electronic device for showing numbers using glow discharge, is another fascinating but niche example. Remember, the field is evolving rapidly, chasing better quality and efficiency. Emerging technologies like micro-LEDs are already being researched and are considered strong candidates to replace OLED and LCD in the long run. That's it for today. Thanks for watching, subscribe for more, and hopefully see you soon.